Solving quadratic inequalities. So we have these two visual representations of quadratics. We have their parabolas drawn right here. And if you look at this first example, if you were asked the question, where is your quadratic or where is this parabola greater than 0? So here is our x-axis. And of course, when you're on the x-axis, right here and here, our parabola or our function has a value of 0. If I move to the right, this section of my graph is positive or greater than 0, and this section of my graph is positive or greater than 0. But if you were asked where is your function less than 0, you would be looking for this section of the parabola. And the same is true, same sort of concept over here for this parabola, this quadratic function that's drawn over here. If you were asked where is this quadratic function less than 0, you would kind of be looking at the legs of this parabola. If you were asked where is your quadratic function greater than or equal to 0, if it says or equal to, we would be including our two zeros here and then this section in between. But we're not always given the quadratics graphed on a coordinate plane for us. So sometimes we're given these algebraic quadratic inequalities and we need to solve them by hand, or maybe perhaps we don't like graphing and we would rather see the algebraic representation. So let's look at that today. Our first example is x squared minus 6x is greater than or equal to -5. The way that we're going to start this is kind of the same way that we would a quadratic equation. We want all of our terms on one side. So we're going to add 5 to both sides of our inequality. And there are no like terms here to combine, so that leaves us with x squared minus 6x plus 5 is greater than or equal to 0. So now I've got this quadratic expression and the a value is 1, so it's pretty easy to factor. The factors of positive 5 that combine to give us a -6, or this -6 right here, is going to be -5 times -1, or -5 plus -1. So the factors are x minus 5 times x minus 1. And that should be greater than or equal to 0. Now, if you don't remember how to factor a quadratic, I would encourage you to go back and look at the factoring videos that I have uploaded for you guys. So we have this quadratic expression should be greater than or equal to 0. Again, we're going to kind of treat this as a quadratic equation. And when I multiply two values together to get 0, that means either my first factor has to equal 0 or my second factor has to equal 0. So let's do that. Let's say x minus 5 could equal 0 or x minus 1 could equal 0. And then when I solve for x on both of these, add 5 to both sides for this first equation, and we get x equals 5. And for the second equation, add 1 to both sides, and we would get x equals +1. So these two values right here, +5 and +1, represent the roots or the zeros of my quadratic. So I'm going to go ahead and sketch myself a number line. And anytime I have a number line, I like to put 0 as a reference point. It's not necessary, but it's a habit. I like doing it. So I'm definitely going to put on there the 1 and the 5, the +5 and the +1. Now my inequality says up here that I want my expression to be greater than or equal to 0. Because of the or equal to, we are going to place closed circles on the number line here at +1 and +5. Now, the way that I like to do this, the fastest way that I think it is, or at least for me, and it's fine if it's not for you, is I look at this quadratic and I notice that the a value is a +1. Okay, it's an understood 1 right there. Now, because it's positive, that means my parabola is going to open up. If my a value were negative, my parabola would be opening down. So I'm just going to sketch a picture of a parabola that opens up. And then it's pretty easy for me to tell where my quadratic is positive and where it is negative. If I want the positive values, it's everything that sits above the axis. If I want the negative values, it's everything that sits below the axis. Now, if you're not familiar with what a quadratic graph looks like or how to graph it or, why that is, or maybe you just like number crunching, that's fine too. Let's go ahead and choose a value to the left of +1. And I always like to choose 0. It's the easiest value to substitute into an expression. So if I have 0 minus 5 and 0 minus 1, both of these values would end up being negative, right? Okay, so I would have a negative value times a negative value. What is a negative times a negative? Well, that would give us a positive value. And you can see on your graph right here, everything to the left of 1 is positive. Now let's choose a number between 1 and 5, and it doesn't matter what value we choose as long as it's between the two, so I'll just choose 3. If I take the number 3 and I sub it in for my x values, 3 minus 5 is negative, but 3 minus 1 is positive. And you see, I'm not even actually getting the numeric value. I'm just making sure that it's negative or positive, right? So a negative times a positive will give me a negative value. And you can see from the graph that we already created, this section of my graph is negative. And then I need to choose a value to the right of +5. I need to go to the right of +5. So let's try 6, okay, or 10. It doesn't matter what you choose. If you take the number 6 and you sub it in for your x values, 6 minus 5 is positive and 6 minus 1 is positive. Both of these are positive. And of course, a positive times a positive gives us a positive value. So we've got this set up, whether you like looking at the graph or you like looking at the numeric values and just subbing in answers. Again, I want to know where my quadratic is greater than or equal to. So my greater than sections, let's go ahead and highlight, are here and here. So how am I going to write that as a solution? How do I make this a solution showing all of the values that are to the left of +1 and to the right of +5? So everything to the left of +1 and including +1, we would say x is less than or equal to 1. And for the next section, I would say x is greater than or equal to +5. And because both of these solutions work, it could be either x is less than or equal to 1 or x is greater than or equal to +5. And those are your solutions. That's your solution right there. All right, let's look at another one. We have negative 2x squared minus 12x minus 16 is greater than 0. It's already set equal to 0, or all of the terms have been moved to one side. So I'm going to go ahead and start factoring. And I notice that there is a -2 for a GCF. So I'll factor out the -2 first. And that leaves us with x squared plus 6x plus 8 is greater than 0. So now I need to factor. I have a +8 and a +6 right here. What are the factors of 8 that combine to give me 6? Well, 4 times 2 is 8, and 4 plus 2 is 6. So my binomial factors are going to be x plus 4 and x plus 2. And of course, I'll just bring down my -2 and greater than 0. All right, so when I multiply the -2 and my binomial factors together, if I were to get 0 exactly, that would mean that one of these factors has to equal 0, right? Well, -2 can never equal 0, so that's not going to help me out at all. But I do know that x plus 4 could equal 0, and x plus 2 could equal 0. So if I want to isolate my x values, if I subtract 4 from both sides of my first equation, I get x equals -4. And from my second equation, if I subtract 2 from both sides, I get x equals a -2. So here again, we're going to go ahead and draw our number line, do a rough sketch, and -4, -2, and of course here's 0 for a reference. And now let's look back. I see right here, well, actually in all three of these steps, I have an inequality symbol that is greater than. It's only greater than. So I don't want a closed circle anymore on my zeros or my roots. I want open circles at -4 and negative 2. Negative 4 and negative 2 are not going to be part of my solution. Okay, so now let's look back at our quadratic expression again, and I want you guys to recognize that our a value is a negative 2. In all three of these examples, we can see that our a value is a negative 2, which just means that we are going to sketch a parabola that opens down this time. When your a value is negative, your quadratic opens down. And again, it doesn't matter how good the sketch is. We're just wanting an idea of what's happening with our graph, right? So let's look, and we can see that everything to the left of negative 4 is positive. Everything between, no, I am so sorry. It's not positive, it's negative. It sits below the x-axis. So everything to the left of negative 4 is negative. Everything between negative 4 and negative 2 is positive, because here it sits above the x-axis. And then everything to the right of negative 2 sits below the x-axis, so that section is also negative. All right, and again, you can feel free to always substitute in values if you would like to. So if I want my values to be greater than 0, where is my function greater than 0? Well, it's greater than 0 only right here in this section. Okay, and remember, we don't want to use negative 4 and negative 2 as part of our solution, so we're only going to be using the inequality symbols without the or equal to. So negative 4 is going to be less than x, which is going to be less than negative 2. And those represent all the values between negative 4 and negative 2. So those are our solutions, how we get them algebraically. And if you go back and look at the original graphs that we have drawn, for our first example, we wanted to know where our quadratic was greater than or equal to 0. We got these sections of our graph, which of course matches these answers here. And then for our second figure, we wanted to know where we were greater than 0, which was that middle section there, which is of course what this inequality says here.